Hello, everyone, and welcome back to the afternoon session. We have three fabulous speakers. I am Amy Lewis. My official title is Director of Influence Marketing, and obviously we're attempting to influence you with massive amounts of sugar and excellent content, so I hope you've been enjoying that. Just a quick bit of housekeeping. I want to make sure that we thank all the speakers we've had and that are coming up, and also a special thank you to Kelsey Cook, who has been running this operation flawlessly. So if you get a chance, please introduce yourself. Also Katie Holmes outside running our podcast, and of course we've got Bruce and Guido and Pere, who have done an excellent job forming the content and sessions today. So if you have an opportunity, please introduce yourself and say hello and a thanks. It's been great to work with them. Now, without further ado, may I introduce our next speaker, Wang, who is the CTO and co-founder of Zingbox, and she is going to give us a talk on security and enterprise IT, and I'm very much looking forward to it. So, May?
Good afternoon, everybody. So today I'm here together with my partner Xu from Zingbox to talk about new security challenges we're seeing in Enterprise IoT. And Zingbox is, just a few words about Zingbox. We're based in Silicon Valley. We provide security solutions to protect connected devices in your enterprise. We're actually Zingbox without real box because we're a pure software solution. I'm sure you have listened to many visionary talks, philosophical discussions about IoT. Today, instead, I hope to show you some facts and data from real world about where IoT is today and what are the challenges in terms of security. Before I show you the data and graphs, charts, I'd like to highlight a few special characteristics we are observing in the real world. Special behavior patterns from these connected devices compared to our traditional IT devices, our good old IT network, in terms of security. Encryption. 4 years ago, when Xu and I started Zingbox, together with our amazing team of founding staff, we designed all our algorithms and data analytics mechanisms based on assumption all traffic is encrypted, like in the traditional IT world. But very soon, we discovered that's not quite true. Actually, it's very not true. We found there are two verticals, healthcare and manufacturing, showing the most urgent needs in terms of IoT security. So today I'm going to mainly use these two verticals as example of what we're seeing, even though lots of traits we're seeing are across the board for IoT devices. Among more than 200 deployments we have in the field, in healthcare, we see less than 1% of IoT traffic is encrypted. Manufacturing, a lot better, 5 times better. We see less than 5% of IoT traffic is encrypted. Lots of these devices are in critical infrastructure operations. So having operation continuity is very key for these devices. I know for most of us, it's very challenging for us to, during this 20 minutes talk, without checking our phones, without checking our laptops. If our phone or our laptop dies, it is killing us. But when it comes to operation devices, especially in healthcare, the degree of assassination we're talking about is totally at a different level. From our research lab, we actually demonstrated we can hack through an infusion pump and change the dosage of medication goes to a patient, and that can kill the patient right there. Last year, WannaCry affected many organizations, many hospitals, many manufacturing plants. One very large healthcare organization got affected. Its CISO got a list of IP addresses of the devices got affected. But he has no idea what these devices are. Are they X-ray machines? Are they infusion pumps? Also, he had no idea where these devices are being used right now. Any of them is being used in surgical operations or in ER, saving a patient. So the only thing he could do is to watch WannaCry spread out in his organization. It's not like in the IT world, we can just quarantine the device once we found there's some vulnerability in this device. We can just disconnect it from the network because the operation continuity is really life and death, especially in healthcare. Patch. We see many Windows 98, Windows XP systems are controlling X-ray machines, MRI, CT scanners in hospitals without patches. That's another special characteristic about these IoT devices. We change our cell phones, we change our laptops every other year, every 3 years. These devices have been in the field for 10, 20 years without any patches, without any upgrades. Imagine you're still using your laptop from 1990s, using your cell phone from 1990s without any upgrade, without any patches. And the reason is, there are several reasons. Compliance reason. We all know healthcare is a very heavily regulated system. Once you pass the HIPAA compliance, it's a very tedious, long process. Nobody wants to touch the device again so that they don't have to go through the process again, even though FDA came out, clarified that not all updates and upgrades you have to go through the same process, but still, people don't want to touch these devices again. Operational interruption. We heard over and over again. It happens so many times when the organization, staff at the organization trying to patch these operation devices, it broke the device. Even though the patch was tested again and again in the lab, but somehow when it's deployed in real field, it can break the device. And also, these devices not only carry IT trace, but they also carry operation values and also business values. We all know for every single minute on the production line, it costs at least tens of thousands of dollars of the manufacturers. Similar thing in hospitals. Every 15 minutes, an MRI machine is down. It costs $5,000 for this hospital. So these are cash cows for these organizations. Firewall. We actually see most traffic are still internal traffic. Not all the medical devices, all the IoT devices going outside of their network that frequently. So firewalls don't really catch east and west traffic. And also, for these devices, firewall doesn't have any context about these devices. Just give you an example. Lots of X-ray machines are being controlled by Windows operating system. If it is a Windows operating system on your laptop, it is perfectly okay to use FTP protocol. But it's not okay if it's controlling your X-ray machine. But firewall doesn't really have that context. All it sees is, okay, this Windows operating system is sending FTP protocol, and that is perfectly okay. Device security. Most of these devices don't have security by design. They don't come out of manufacturers with the kind of security capability as our laptop and cell phones. And also, lots of them, you cannot really download, install an antivirus agent onto these devices. So the capability they can protect themselves dramatically decrease. Scan. In manufacturing, there used to be vulnerability scanners, but very soon they discovered that these scanners can actually break these machines. So now in many manufacturers, they don't allow any kind of active scan of these devices. Onboarding. Many of these IoT devices don't really have the traditional IT onboarding capability. For example, lots of devices, they don't even have password login name. You cannot do two-factor authentication on these devices. SIEM relies on syslog. Lots of these devices don't even generate syslog, needless to upload their syslog into a SIEM system. And lots of these operation devices, IoT devices, actually are managed in the organization by a different group of people who are experts in operations, whether it's in hospital or in manufacturing plants. But all of a sudden, now they need to worry about the connectivity of these devices, the security of these devices. They know a lot about medical devices, they know a lot about robots and controllers, but not necessarily they're the experts of security and IT. So what we see most organizations are doing right now to protect these devices is just using microsegmentation. And let's take a look at microsegmentation. Let's use medical device as an example. You would expect a VLAN specifically designed to protect these medical devices should look like this. Majority of the devices on this VLAN should be medical devices, or very few of other devices. What we're seeing, this is what we're seeing. A very large percentage are PCs. Only a quarter of the devices are medical devices. Then there are a whole bunch of other devices. And in terms of numbers VLANs we're seeing in organizations, majority of them have less than 20 VLANs. And these are huge organizations we're monitoring. So that means most of the network architecture structures very flat, fairly flat. And there's some crazy ones. We see organization with 3,000 VLANs. Imagine the amount of work to configure these VLANs, to manage these VLANs. So this chart basically tells us we don't have, or the operational teams don't really have a good idea what would be the best number of VLANs configuration to protect these devices. And that's exactly where our IT people, our networking experts can contribute and help here. And actually, I want to show you more insights from large amount of real-world data we collected through the whole year of 2017, even though they're only a small sample of all our deployments. These are collected from 50 hospitals in the US. And first question is, what are the devices we're seeing? Any guesses in terms of number one, in terms of quantity of devices we're seeing in hospitals? Telephones? Actually, we see the largest number of devices are infusion pumps. And next one are imaging systems, and then patient monitoring. And the top three actually, so here's the 80-20 rules again. The top three actually contribute to 82% of the total number of medical devices we're seeing. Then, any guess on among these devices, which are the most vulnerable devices? Which category shows the most vulnerabilities? Top three? Pretty good guess. Even though infusion pumps have the most number of devices, but the number one category device shows the most vulnerabilities are imaging systems. And we're going to explain why that's the case. And the top three vulnerable devices are imaging systems, patient monitors, and medical device gateways. And they contribute to 86% of vulnerabilities we're seeing. So what are these security issues we're seeing? What are the vulnerabilities? And why imaging system is the most vulnerable device? And we divided these causes into this pie chart. And a guess on the biggest piece of the pie? What are the main causes of these vulnerabilities, security issues? That's a very good one. The first one is actually, again, user practice issues. In that sense, it's kind of similar to what we're seeing in IT world, right? It's always the users, always the people. And that actually explains why these imaging systems are most vulnerable, because they have the full-blown operating systems, so that people, you're not, even though it is Windows system, you're not really supposed to play Pokemon Go on it. You're not really supposed to watch Netflix, but people do. They have rogue applications, they have various unintended, not supposed to do browser usage. And the second category is outdated software and operating systems. And the operating systems without patches and software without upgrades, etc. Then there are lateral movements because they are all connected to IT network, to your patient record system now, and weak password and login name. You can actually Google and get the default login name and password for certain CT scanners. And then, of course, network segmentation, as we mentioned before. So this is the same set of data, but look at it differently. So different category of devices actually have different dominating vulnerability factors. For example, imaging system, it's mainly caused by user practice issues. While for patient monitoring, it's mainly caused by outdated operating systems and software. And for the nurse call system, the major factor is lateral movement. So you can check out the full report at our website. So again, using healthcare as example, these are the questions that bothers CISOs today. They ask about what are the connected devices on my network at any given time, what these devices are doing, how can I avoid next WannaCry, and which device carries critical patient information. So in summary, we actually categorize all these challenges into 3 categories. We call them ISO. I stands for identification. Only knowing each node on the network as an IP address is not enough, because these devices are very different from each other. They have different hardware, software, operating systems. They have different behaviors, and they're supposed to do different things. We have to know what these devices are and what their normal behavior is supposed to be. And S stands for security. Only after we know that, we can further secure these devices. We know their normal behaviors. And as we are seeing and collecting huge amount of data, we actually got lots of requests from customers. Can you tell us more about our operation intelligence, about our business intelligence, about the usage of these devices so that they can further increase revenue and reduce costs, provide better services? So facing all these new challenges, what will be a good solution? Well, one solution can be we all go to do more exercise and never end up in hospitals anymore. And we see whatever solution you're providing or whatever solution you're adopting, we think the following characteristics will be very important to protect these IoT devices. There are lots of philosophical discussions about agent, agentless, whether we do that on each device or we do it at the network level. We think given the scale of IoT devices, given the diversity of IoT devices, it will be very challenging to do device security on each single device, given so many vendors, so many different types. That's actually make our work and network become even more important and critical. And we think agentless solution would be a lot more scalable and easier to deploy. As we mentioned, it's very, very important that we understand these devices. We understand their personality. We know whether this is X-ray machine, an IV pump, or controller or robot. We need to understand these devices. Not only understand who they are, but we understand what they do, what they are supposed to do, what they're designed for. what the fixed set of functionalities that they're designed to do, and so that whenever they do something abnormal, we can catch them easily. For some mission-critical tasks, time-sensitive jobs, it's impossible we send everything up to the cloud. Huge amount of data we're seeing, so we have to do some process, do some intelligence at the edge. So we think edge-cloud combination is very important. Microsegmentation. We need to put more intelligence, feed in more intelligence to do a better job on microsegmentation. And that's also where we all can contribute a lot. We need to first, as mentioned before, know what these devices are before we can figure out which VLAN we should put these devices in. There are lots of challenges IoT devices are bringing to us, but one good thing these devices are bringing to us is huge amount of data, not only generated by human, but more and more data are generated by these devices. And we nowadays can have access to this huge amount of data we either couldn't have access before or couldn't access them in such real time. So we should really leverage the huge amount of data 24/7 generated automatically. There are lots of insights, intelligence we can get out of these from analyzing these data. And whatever solution you're generating or adopting, really need to scale. Again, lots of these operation devices are managed by operational teams. Not necessarily they can be security and IT experts. So we cannot continue designing product solutions for the operational team that require certificate in order to use the product. So easy to use, hide all the advanced technologies behind the scene, make everybody easy to use the product is very important and automatically. So what will be a solution that fulfill all these requirements? I know you all fall into sleep hearing artificial intelligence because you've heard about it so many times, and I'm totally with you. And that actually reminds me of a story many years ago when I started graduate school doing research together with Xu and Guido at a small college in Silicon Valley. I was trying to figure out what area I should do my research in. And my, at that time, landlord said to me, "May, let me give you a piece of advice. Whatever you do, don't do artificial intelligence." Because I have a friend who got his PhD from Stanford in artificial intelligence, and for 20 years, he couldn't get a decent job. And for me, I majored in physics for my undergrad, and only then I learned there's another subject on this planet can make me even more jobless. Despite all the recent advancement and hype about artificial intelligence, it is still not as smart. We still have a hard time to make machines as smart as human beings. If you ask me what is May's normal behavior, I don't even know what my normal behavior is. How do you expect artificial intelligence, machine learning can figure out my normal behavior? But one advantage we have from these IoT devices, because they're designed for a fixed set of functionalities, their behaviors are relatively simple, more predictable, fixed patterns. So that's perfect for these machines to pick up their normal behavior. And the challenge is how you scale up to billions of devices. That's exactly where we see artificial intelligence can give us lots of help. And during past 4 years of R&D and 2 years deployment in real world, and we start seeing real promising results using artificial intelligence. And thank you, and welcome to contact us for any questions. Thank you.
Nobody's got a question? Well,
very much. This was a very enlightening presentation. In your mind, do you think, since you were talking about AI being the potential solution here to predicting the behavior of things that might have behaviors, do you think in your mind it is time for medical devices and devices of that nature to go back to being essentially printed circuits, effectively ARM chips with small programs that don't run Windows and therefore don't run Pokemon Go or Doom 4, that only do imaging device work or what they were intended to do, so that when you monitor them, you can tell exactly what they're doing, what they're supposed to do. Because there's only 3 or 4 things they're going to do. And behavior might not require AI. It might just require a red flag to say, hey, that's looking a little weird.
Yeah, I'm sure there are reasons these CT scanners, X-ray machines, MRI machines chose Windows system to control these super complicated machines, because it's not very easy to design a very sophisticated operating system from scratch, and that might not be the expertise for the medical device vendors as well. So then I think there have been lots of debates on whether we should proprietary solution, we should a more generic platform, etc. I think it takes all parties, all different kinds of solutions and contribution eventually to mitigate the device security, and all possible solution can be tested, can be viable solutions. Yeah, but no matter what, because of the special characteristics of these devices, the good thing about Windows system is it's very vulnerable because it's deployed with such large deployments, and that's why there have been lots of hacking incidents. And then on the other extreme is you can design proprietary operating systems applications if it's not that widely deployed. Maybe it's relatively secure, but on the other side, probably from the feature, from support, from lots of other things, it requires lots of special customized effort as well. Yeah, so I think there'll be trade-off and balance.
Actually, so I have a question. Very enlightening talk, and it certainly makes you want to stay healthy, looking at some of those statistics. Now, at the end of the day, it's not completely surprising, right? I mean, your typical doctor or nurse is probably not particularly good in dealing with complex IT equipment. But that being said, if I think of my home network, which is accumulating more and more IT devices, like Internet of Things devices, how is that going to look like, right? I mean, I'm in the double digits, mid-double digits now of IP addresses at home. Once we start with digital, bit of smart light bulbs, and we're probably in the hundreds. How are we going to secure home networks?
Very good question, Guido. Actually, when we started Zingbox 4 years ago, we were considering doing home network security. But at least at that time, we did a market survey. It wasn't really ready yet. But I think moving forward, we do expect your home can be a small enterprise without IT department, without IT experts. So then the question is, we need, whether it can be service providers, can be special security providers, whatever, device manufacturer, there needs to be services that provided to home network to protect all these network devices. We do see actually during the past, I would say a year or two, we start seeing more interest from ISPs because they are already connected to millions of homes. They are interested in protecting these devices. I think there definitely needs, very similar to the OT world we're seeing, because you cannot expect everybody become security expert, become IT expert. We definitely need easy to use software, easy to use program, services provided to help us protect all these devices. There's a question there.
Thank you so much. This was eye-opening. I immediately think of the accountability of the vendors. Is there data of vendors that have a good track record of maintaining and supporting their solutions over time.
You're talking about device vendors?
Yeah, in healthcare mostly.
Yeah, very, very good question. You know, before, if I were a device vendor, I sell you the equipment, I tell you how secure it is. Most customers have no way to even tell how secure it is. But if we have a software in place, tell you among all these X-ray machines you got from 3 different vendors, what they're doing every day, what protocols they're using, you can easily figure out which one is more secure. And then when you're doing procurement next time, you know naturally which vendor you're going to go to, or at least for the vendors didn't check all the items on the list, need to improve. We do see the momentum from the customer side are pushing device vendors to create more secure devices out of the factory. But again, also we understand whether it is for the program logic controllers in manufacturing floor or medical devices, these can be very sophisticated equipment. It takes years to design them. And even when they understand the device vulnerabilities, they want to put security at design at the beginning. It takes a long while for you to see a more secure product back to the market. But yes, again, we definitely need all parties collaborate and work together, make the whole IoT network more secure. Yes.
So I actually work in the space, and I really appreciate what you did there. I've got a follow up on that last question. Is a lot of our providers and departments love the sales pitches, and don't necessarily involve us until it's already gone past the point of no return in some cases. What kind of philosophy or strategy would you espouse there, other than just saying no or injecting ourselves into the purchasing process? What other strategies do you think are more healthy than that?
I think from device vendors, they definitely would love to hear feedback from customers and requests from customers. I think that would be I see two sides. One is from the customers, give them feedback, give them your requests, and especially when you do have the inside information, you can tell which device is more secure and which device is causing security issues, and you can give them more insights. And another thing we start seeing is from the regulation point of view, FDA's, HHS are all beefing up their efforts to come up with more regulations to protect these IoT devices, to come out with best practices, both for healthcare providers and to device vendors.
Thanks.
Thank you. Thanks. Thank you.